There's a special kind of shock in seeing life come out of something you had already dismissed. An old patch of dirt in a flower pot, a forgotten roadside after rain, a dry lake bed, a burned hillside, a field that looked empty for years. And then, suddenly, a green thread rises through the soil. Most of us read that moment as chance. Good luck. A delayed accident. We imagine the seed as passive, almost unconscious, like a tiny object that just happened to survive long enough to get wet. But that picture is far too shallow, because when some seeds wait 10 years, or 50, or 100 before they sprout, they are not simply failing to begin. They are doing something much harder. They are refusing to die at the wrong time. That's the first reframe. A seed that doesn't germinate is not necessarily inactive. Very often, it is actively holding itself back. It is reading the world, comparing signals, delaying a dangerous decision until the odds change. What looks like silence is often one of the most sophisticated survival strategies in nature. And once you see that, a seed is no longer a speck of plant matter. It becomes a tiny, living forecast system. The common assumption makes sense. Seeds are dry, still, and quiet. They don't look alive in the way an animal looks alive. No heartbeat, no movement you can see, so it feels natural to think they're basically asleep until water wakes them up. Sometimes that's true in a simple way. But many seeds are not waiting for just any moisture. They are waiting for the right pattern of signals. Not one green light, a whole conversation. A seed is an embryo, a food reserve, and a coat. But it is also a packet of chemical rules. Inside it, hormones are constantly shaping one central question. Grow now, or not yet. Abscisic acid helps maintain dormancy. Gibberellins help promote germination. You can think of them as opposing instructions. Hold back, move forward. The seed doesn't have a brain, of course, but it does have a way of integrating information. Moisture, temperature, oxygen, light, even chemicals in smoke or soil all feed into that decision. That matters because sprouting is irreversible. Once a seed commits, it burns stored energy, breaks open, and begins building a body in the open. If the timing is wrong, it dies. There is no undo button. So, from the seed's point of view, patience is not laziness, and patience is risk management. Seed biologists have spent decades showing that germination is less like a switch and more like a judgment call built from chemistry. Some seeds need cold before they trust spring. Some need light, which tells them they're near the surface instead of buried too deep. Some need darkness because light would expose them too soon. Some need fluctuating temperatures rather than a single warm day because one warm day can be a trap. That trap has a name you already know, even if not from botany: the false start. Imagine a seed germinating during a brief warm spell in late winter. It opens, commits, begins to grow, and then the cold returns. For the seed, that mistake is fatal. Dormancy evolved in part as protection against being fooled, and some plants live in worlds where being fooled is almost guaranteed. In deserts, a one rainstorm may not mean a season has changed. It may mean almost nothing. In fire-prone ecosystems, a seedling that emerges before a burn may be shaded out or starved. After a fire, the same ground can become bright, open, nutrient-rich, and suddenly survivable. In floodplains, disturbance can bury seeds for years before the conditions align. So, evolution did something astonishing. It turned waiting into a trait. Ecologists call one version of this bet-hedging. Instead of letting all seeds germinate at once, a plant spreads the risk. Some sprout this year, some next year, some much later. If one season is deadly, not all the offspring are lost at once. To us, it can look indecisive. In evolutionary terms, it's brilliant. And now the century question starts to make sense. One of the most famous demonstrations began in 1879, when a botanist named William Beal, at what is now Michigan State University, buried bottles of seeds in the ground to test how long they could stay viable. The experiment is still going. Every so often, researchers dig up one of those bottles and try to germinate what's inside. More than 100 years later, some seeds still sprouted. Just sit with that for a second. A seed produced in the 19th century, held in darkness underground through world wars, industrialization, and the entire modern age, still carrying enough integrity to begin again. Not every species can do that. In fact, many cannot. Acorns, for example, are poor long-term sleepers. They carry a lot of water and don't tolerate drying well. Seed scientists call seeds like that recalcitrant. They need to move quickly, and they pay for that speed with fragility. Other seeds, I called orthodox seeds, can dry down and enter an extremely stable state. Those are the marathon runners of plant time. How do they do it? Part of the answer is physical. As seeds dry, their internal chemistry shifts into a state that is remarkably stable. Special protective proteins help keep cellular structures from collapsing. Sugars can help form a kind of glassy matrix inside the cells, slowing damaging reactions to a crawl. Metabolism becomes incredibly low, not zero, just low enough that the seed can persist without burning through its reserves. Part of the answer is repair. Even in dormancy, time still causes damage. DNA breaks, proteins age, membranes weaken. The moment water returns, one of the first tasks is not growth, but assessment and repair. Before the seed stretches upward, it has to see whether it can trust its own body. And part of the answer is environmental sensing, which is where this story becomes less about storage and more about intelligence in the broad biological sense. Seeds sense light using pigments such as phytochrome, which helps them distinguish the quality of light around them. Red and far light can tell a seed whether it's close to the surface or trapped beneath other plants. Temperature changes matter too, not just absolute warmth. Repeated cold can help break dormancy in some species, a process called stratification. Moisture, nitrate in soil, oxygen availability, even the abrasion of a hard seed coat by weather, microbes, or an animal's digestive tract can all be part of the signal. What the seed is doing, in plain language, is asking, not can I grow, but is now survivable? That is a much deeper question. There are even seeds that wait for catastrophe. In fire-adapted landscapes, some species germinate better after smoke or heat. Australian researchers, including Kingsley Dixon, and chemists led by Gavin Flamati, helped identify smoke compounds called characins that can trigger germination in certain plants. To a human mind, fire often means destruction. To those seeds, smoke can mean opportunity. The canopy has opened. Competitors have been cleared. Nutrients have shifted. If you were ever going to emerge, this is your moment. That changes the emotional shape of the story, doesn't it? The seed isn't simply hiding from the world. It is tuned to the world so precisely that even disaster can become a message. And then there are the famous outliers, the seeds that feel almost mythic. The sacred lotus is the classic example. Research led by Jane Shen Miller found that lotus seeds recovered from ancient lake sediments in China could still germinate after many centuries. These are extraordinary cases, not the norm, and scientists are careful about them. But they prove something important. Under the right structure, the right chemistry, and the right storage conditions, a seed can preserve life far longer than our instincts tell us is possible. Still, longevity alone is not the real miracle. The deeper miracle is selectivity. Because many long-lived seeds do not germinate the first moment they can. They wait through opportunities we would call good enough. They reject partial signals. They avoid the seductive mistake. This is where plant behavior starts to feel unexpectedly close to something human. Not because seeds think like we do. They don't, but because we understand, at an emotional level, what it means for timing to matter more than speed. A seed that sprouts too early is not more ambitious. It is more vulnerable. A seed that waits is not weak. It is protecting a future. And seeds are not just responding to the present. In some cases, they also carry a memory of the past. Work on the small lab plant. Arabidopsis has shown that genes involved in dormancy, including one memorably named DOG1, help determine how deeply dormant a seed will be. Conditions experienced by the mother plant can influence the offspring's dormancy. In other words, the environment before the seed even falls can shape how cautious it will be afterward. That means a seed is not just reading the world it lands in, it is arriving with history. Now zoom out, and the implications get bigger. A buried seed bank is often the hidden memory of an ecosystem. Beneath a meadow that looks bare, beneath a wetland edge, beneath disturbed ground, there may be a reserve of future plants waiting for the right trigger. Restoration ecologists know this well. Sometimes landscapes recover not only because new seeds arrive, but because old ones were already there, invisible, holding on. That is a beautiful thought. It is also a warning. Because if the soil seed bank is the memory of a place, then destroying it is more than surface damage. Deep plowing, paving, erosion, repeated severe disturbance, altered fire regimes, or prolonged climate shifts can erase those stored possibilities. A hillside may still look like dirt, but the difference between living soil and biological amnesia can be hidden underground. Climate change makes this more complicated. Many seeds evolved to trust particular patterns, a sequence of cold followed by stable warmth, a fire of a certain intensity, rainfall that arrives in a familiar rhythm. As seasons become less predictable, those cues can become noisier. A false spring can wake plants too early. Fires that are too hot can kill seeds rather than cue them. Rain that comes at the wrong time can trigger germination without follow-up moisture to keep seedlings alive. So the question is no longer just why some seeds wait 100 years. It's also whether the world they were waiting for will still exist when they wake. That may sound heavy, but it reveals something profound about ordinary life. When you look at a patch of soil and see nothing, you may be looking at a field of decisions deferred, at descendants not yet chosen, at a living archive of caution, memory, and hope. And hope is not too soft a word here. Biologically, dormancy is ruthless. It evolved through failure. Countless seedlings died for this strategy to exist. But what dormancy preserves, over and over, is the possibility of trying again. Not endlessly. Seeds do die. Time wins in the end. But life has found a way to stretch possibility across years, across disasters, sometimes across generations. There is something deeply moving about that, especially because plants are so easy for us to underestimate. We celebrate motion, noise, urgency. We trust the visible. Plants often operate in another register entirely: chemical, seasonal, patient, distributed. And seeds may be the clearest example of that hidden world. No face, no voice, no obvious movement. Yet inside that silence is a system evaluating risk, storing history, and waiting for a future it has never seen. So, if a seed waits a century before sprouting, don't imagine a tiny prisoner trapped in sleep. Imagine a survivor holding a line. Imagine a life so disciplined it can say no to rain, no to warmth, no to apparent opportunity, until the world becomes less lethal. Imagine chemistry doing what we usually reserve for minds, integrating signals, comparing conditions, choosing between immediate action and delayed survival. That doesn't make seeds magical. It makes them more interesting than magic, because it's real. A century-old germinating seed is not a glitch in nature. It is nature showing you how much intelligence can exist without a brain, how much behavior can hide inside stillness, and how often what we call passive is actually strategic. And maybe that's why these stories stay with us, because somewhere in that small, dry object is a lesson we recognize instantly. Not every delay is failure. Sometimes waiting is the most active thing a living being can do. The next time you see a sprout appear in a place that seemed dead, pause before you call it random. That seed may have been listening to seasons longer than any human nearby has been alive. It may have crossed drought, shade, burial, heat, cold, and time itself just to choose this exact moment. That is not small. That is one of the great hidden dramas of life on Earth. If you've ever seen a plant appear out of forgotten soil, after a fire, after heavy rain, or in a place that felt impossible, tell me about it in the comments. I'd love to know what changed the way you looked at that moment. And if you want more stories that reveal what plants are really doing beneath the ordinary, subscribe, because the quietest things in nature are often the ones with the most to say.